Okay, now that we've got a little bit better understanding of what problems occur with Android because of its design constraints on where threads can run and which threads can access which kinds of components and so on, let's talk in much more detail about its concurrency frameworks. And we'll see that there are going to be two of them. And we'll talk about what these different frameworks do. There's the handlers, messages, and runnables, or the hammer framework, and there's the AsyncTask framework. All right. So there are two frameworks, as I've indicated before. The hammer framework allows background threads to do potentially blocking computation. So you can have operations, and I should really say potentially long-running or blocking operations, run in one or more background threads. And as those operations complete in the background, they can then go ahead and post or send the results of the operations to the user interface thread. And it does this by putting them into a message queue. And this message queue is managed by a so-called looper. And the looper will pull stuff out of the message queue and then dispatch it to the appropriate handler so that the work gets done in the user interface thread. So that's the hammer framework approach. And the second approach is the AsyncTask framework. And it sounds very similar at first glance, but there's an important distinction here. So once again, you can have operations run in one or more background threads, and these threads can publish results to the user interface thread. But the cool thing about the AsyncTask framework is application code doesn't have to manipulate or create or know anything about threads, handlers, messages, or runnables. Whereas with the handlers, messages, and runnables framework, as the name implies, the applications have to know a bit more about threads and handlers and messages and runnables. So they have to do a little bit extra work. There's more pieces they have to keep track of. Whereas the AsyncTask framework hides all of that stuff from the application developer, and they just have to worry about using well-defined patterns like the template method pattern in order to subclass from a base class or superclass called AsyncTask and then override some of its hook methods, one or more of its hook methods. Both frameworks have pros and cons, as with everything, and they're used extensively throughout Android. So if you were to go look at the Android source code, for example, and the Android apps that come out of the box, you would see an unbelievably large number of usages of both of these frameworks. And we'll see that there's a bunch of different variants. So we have AsyncTask, that's one of the things. And then we have a couple different ways of using the hammer framework to post runnables or send messages. And these can be compared and contrasted along several different dimensions. So there's sort of usability. How easy is it to use this thing? And there's how easy is it to use this thing for simple use cases? How easy is it to use this for more complicated use cases? And you'll see that one of the nice things about the hammer framework is it works really well for simple stuff, but if you start getting into more complicated things, it doesn't work so well. Whereas the AsyncTask works nicely for both. There's also the question of scalability. If you want to have more than one thread around to do computations, how easy is that to handle? Well, AsyncTask, as you'll see, because you do it for your next assignment, allows you to have your own pool of threads using the Java executor framework. And so you can decide to have the threads run in pool. Whereas with the hammer framework, you have to do a lot more work manually, so it's not as easy to use for that. There's also some issues about flexibility and efficiency, and here you kind of see different trade-offs. So posting runnables and sending messages is very, very lightweight. The framework does a little bit of stuff for you, but you get a lot of control over things. So it's a little bit more efficient, whereas the AsyncTask framework has a bit more mechanism built into it. If you need that mechanism, it's great. It's a lot more scalable. It's a lot more usable for complex use cases, but it's also a little bit more overhead. And likewise with respect to flexibility. You can program all kinds of things with message passing. And AsyncTasks are cool, but they constrain you to have a bit more of a particular form factor to the way you do concurrency. So we'll obviously talk a lot more about these things. In general, the idea here with both of these frameworks is to decouple the user interface interactions, which always have to go through that one thread, from other computations and communications that may take place in background threads. So the basic idea is that you have long duration, potentially blocking operations running in the background thread or threads. And that's either done for you in the AsyncTask framework or you do it yourself if you're using the Hammer framework. And then short duration user-facing operations can run in the user interface thread, of which there's only one. So that's basically what we're doing. We're decoupling the user interface operations from background operations, and they can run in different places. The way that this thing works under the hood is we've got the Android infrastructure, which involves message queue, a looper, and then various handlers and messages and runnables. These are all the mechanisms that are available. So this is kind of showing you what you get with the Hammer framework. And I've got a really cool little app called Simple Image Downloads, which does the same processing. In other words, it downloads images and displays them, as the name implies, but you can do it with runnables, messages, or async tasks. So it's like a Rosetta Stone where you keep the logic, the behavior the same, but you change the mechanism by which the implementations take place. So this is the Hammer framework approach. We're downloading images in the background in threads that we spawn, and then as those things complete, they stick them onto this message queue, and that message queue is used to pass results from the background thread or threads to the user interface thread where it gets displayed. So we'll see that the AsyncTask framework has kind of the same feel to it, except that you have less work because it's handling the mechanisms for you under the hood. And that's actually what we're going to focus on in this class. We're not actually going to spend much time talking about the Hammer framework at all. We're going to spend our time talking about the AsyncTask framework.